one, remember what we said. The directions say, go to the x equation, solve for t. Then in the y equation, you substitute in what you found for t with the x variable. So that now we've got your rectangular equation, an x and a y. So if I slide this into here, here's my t. I slide what we found. We still have to square it. I can actually, you've got to follow order of operations. So actually just keep the top squared, square the bottom, and then you can reduce that. Be careful, don't cross out the 2's first because you got to square it first. So reduce it. Then we said, okay, find a common denominator. And I actually subtracted 2 from the other side, don't ask me why. And then, looks like I multiplied by 2. We set this up into a parabola, that's why. Okay, so this, and you could do it the other way if you like to. You could set it up the other way. You could put this over 2 and do x minus 7 squared, and then your denominator is 2. You would need plus 4. You could do it this way. Not the best way to do it, but you could. You could kind of see that it's a parabola. Separate it. Yeah, probably get it into parabola form. That would be best. Either way, God bless you. As long as you can graph it and see that it's a parabola with an xy point versus a parameter, that's fine. Did any of you graph the parameters, the parametric equations first to see what they look like? No? That's sometimes good to do. It kind of gives you a hint of what you're looking at. Yes? No, you don't equal the x to the y. You take the t and you substitute it with an equivalent equation in terms of x. The reason I did this part here, on your here, because you can kind of see this is a parabola setting up. So remember we put the square on one side and everything else on the other side? So say, for instance, I subtracted 2. Okay, then I multiplied by 2 to get this out of here. Let me switch this around. Remember parabolas went on this side with the squares? Remember the 4p and the x, y minus h thing, y minus k? That's this piece right here. So it's equal to 2, y minus 2. There's your 4p. There's your setup for your parabola. If you spotted it, this is best. If you're going to graph it in your calculator, this up here is probably the better way to put it in your calculator. So we recognize that as a parabola. And graphing the parametric part of it will show you it's a parabola. Stop me if you have any questions. Okay, again, we have an x and a y. We have another parabola. So solve for t in the first part and substitute it into the t in the y equals. Now, because this was a y squared, you actually could do it the other way if you wanted to. If you're going to set up the parabola, only really in this part because this is where your square is. If you solved for t in this one, so y minus 3 divided by 6, y plus 3 divided by 6, and you plugged it into this, that might help you set up the parabola a little bit better because it's going to be a y one that's opening the other way. If you did your parametrics, you can it kind of gives you a hint. You're getting the y squared. It's opening to the side. So if you wanted to set this up, this is going to give you your y squared. So this is going to give you your y plus 3 over 6 squared. Okay, and then you can square this first. Reduce it, or find a common denominator. Add 6 to the other side. And then, multiply by 36, and then you can get there and set up your parabola. This is probably the easier way to approach this one, since you've got a y squared. Okay?
It was under x plus 6. That comes up to.
I just reduced this and this. I put 4 into this, 4 into 36, 4 into 8. When you're here, you can reduce this. You can reduce that. Alright, so in other words, you're left here. Let's follow this through. Add 6. So I just reduced it by 4 to give you, just a little. If you wanted to multiply by 9 and divide by 2, that gives you your 9 halves. Your 9 halves on this side. If you see it over here, take its reciprocal. So if you multiplied this side by 9 halves and this side by 9 halves, cross multiply. Let's do it easier. So you get this. Now divide by 2. There's your 9 halves. And let's switch this to the other side. Here's your 4p, that's your 9 half, x plus 6.
Okay.
See it? There's your 4p part of your parabola. So in this case, it might have been a little easier to go the other way. And if you get it to a y equals, you can absolutely check it on your calculator. If you plugged it in here, and just into this step alone before you resolved anything, there's your y equals. So this is your rectangular equation. You can plug into your y equals in your calculator and see, in fact, if it is a parabola. But the problem here is it's not going to graph both of these. So it may give you an error because you can't put a negative number underneath your radical. I don't know if it'll stop or if it'll give you one piece of it, but that's why it probably won't be able to go much further than that. Okay, these guys, you have to know your one identity here. Sine squared plus cosine squared equals 1. And we solved for your parameter, which is your t, is your angle, is your parameter. But you can't separate t from the word cosine. So solve for cosine t, solve for sine t. Now, if you graph those in your parametrics, you're going to see that it makes an ellipse. So you know you're getting your setup of your ellipse. So therefore, you know you got to square those two. And what identity gives you that is your cosine squared plus sine squared equals 1. It also is nice because it sets up the equal 1 for your ellipse formula. So we plug it in and we square it. And in this case, it came to a circle. Because your denominators were exactly the same. A circle is just a special form of an ellipse. The center is the HK thing. It would be like x minus h, y minus k. So since
wouldn't the center be 0, 0 because
yep.
the x and the y are 1?
Well, because you didn't have anything in here. Yep.
It said 0,
it was 0, 0.
You wrote 0, 0.
Oh, okay. Sorry about that. Mistake. I was probably ready to write radius equals 3, and I probably was doing two things at the same time. So your center is 0, 0. Yes. We move on to the next one. Set up the next one, guys. It's just another form of this. Hi, good. How are you? Yes. Really? Okay. Yes. I'll send them to the girls' gym. Okay. Thank you. Erin, they want you. Yale wants you this time. Ooh. Girls' gym. Coaches in the girls' gym. If you want, just go on the website and it'll be out there to check. Okay, now we have one identity that you know and love. Cosine squared plus sine squared equals 1. Now, easy way to get to a secant and a tangent. Tangent is sine over cosine, right? So I come to my sine and I say, well, if I divide this by cosine squared, I'll get tangent squared. So therefore, this is an equation. Divide everybody by cosine squared. As long as you know your one identity, you can get to the other. This cancels to 1 plus tangent squared equals secant squared. There's the identity that you need to use. And you just have to manipulate the pieces and set them up so that they fit in. So now plug in your tangent, plug in your secant, square it. You remember that everything is on the same side, so you subtract this guy to the other side, and you have a hyperbola. If you graph these, you can see the hyperbola. Really, when you have a parametric, put it in your parametric mode and graph it. If it's any of the trig functions, your t is 0 to 360. It came off the x transversal because the x was first. Good? And use your identity. If you wanted the secant, if you wanted the cosecant and the cotangent, then you would divide everybody by sine squared. But you're going to use the secant and the tangent for the hyperbolas. Alright? Again, this is a circle, but we didn't know that at first. So we set this up, and we set it up like an ellipse. It's a special ellipse. If you left it as an ellipse, that would be fine because it's a special ellipse. But it's easier when you look at it with the center and the radius, whichever you like to look at it. So you have your center and you have your radius. Okay. Some of these weren't so bad, right? And
I couldn't see those.
yeah, I apologize on some of yours. It got wiped out. I don't know why. Jada, put your phone away. Okay, so now treat your t like one angle, just like we did yesterday. It just is going to go around a little faster. That's all. So now put your sine and your cosine in, plug it in, square it. You have an ellipse, center 0, 0. Your major axis is your y because that has the bigger denominator. So it goes up 6, down 6. There's a 6, there's a 5. Okay? Kind of basic ellipse. For those of you that didn't get this on there, sorry. Our top-notch copy machines. Well, not always top-notch.
So that was a square. Sine squared instead of the 2.
It was a 2t angle, but you can treat it as one angle. It's just a double angle. Okay? And this guy, again, you have another ellipse. You can kind of tell because the numbers next to the coefficients of the cosine and the sine are different. Those are the guys you're dividing by. So they're different. You can kind of see the term by itself is part of your center. So there's your ellipse with the center of negative 6, 2. Your major axis, again, is your y because that has the larger denominator. Good? I think that was it, right? Are there any